so what we're going to do today is finish off this last example from 4A and then go into 4B, and then we'll save 4C until Wednesday when we've got our teams meeting. Okay, so this is only 3 parts to this chapter, though. It's pretty quick and easy, and then we'll start looking at the next topic after that. So here we've got f of x equals 2 plus x over 1 plus 5x with the root around that last term. So we want to find the x squared term in the series expansion of f of x. So we're going to go through and run and do the expansion right from the start. So we've got to have A. Now, whenever you've got a reciprocal function like this, where you've got a fraction, the first thing we're going to do is rewrite it so that we have 2 parts, and it's all written as one kind of polynomial-like term, not as a fraction. So we're using our index laws, so we've got 2 plus x, and then we're going to have 1 plus 5x. Now we know the square root is power of a half, it's on the bottom of the fraction, so that's the power of negative a half. Okay, from here, now we can see this is the part that we've got to do the expansion for. So for the moment, we're just going to focus on this 1 plus 5x to the power of negative a half, and then we're going to bring in the 2 plus x later on. Okay, so if we focus on this, we've got 1 plus 5x to the power of negative a half. Now if we expand this out, we end up with 1 as our first term, plus negative a half times by 5x. Okay, so that's your nx, plus negative a half times by negative 3 over 2 times by 5x squared, all squared, over 2 factorial. Okay, and then I'm just going to do the cubic bit down the bottom here. Yes, we're going to add in the cubic bit down the bottom. And now I can see, it says here, find the x squared term. So that might not make sense right now, but whenever you've got kind of 2 parts of your function like this, it's really important that you expand a little bit more than what you otherwise would. And that'll be clear in a minute. Okay, so then we're going to have plus the cubic part, which is negative a half, negative 3 over 2, negative 5 over 2, remembering we're just subtracting 1 from all of those, 5x all cubed, over 3 factorial, which is 6. Okay, so then we can simplify that, and we end up with 1 plus 5x to the power of negative a half is equal to 1 minus 5 over 2x plus 75 over 8 x squared, okay, minus 625 x cubed over 16, okay, and then plus etc. Okay, because we know that that continues on infinitely, that expansion. Okay, so I'm now going to bring this in and put it back in with my 2 plus x. Okay, so I'm going to have here f of x equals 2 plus x 1 minus 5 over 2x plus 75 over 8x squared minus 625 x cubed over 16, etc. Okay, so I've brought that back in. Now, all I need to do here is think about, if I'm finding my x squared term, I need to think about which parts of this function are going to give me an x squared term. Now, obviously, we're going to end up with an x squared term when we multiply 2, if we just think about, kind of like our FOIL rules type of expansion, okay, we multiply everything together. If I multiply the 2 by the 75 over 8x squared, that's going to give me an overall x squared variable. Okay, so I would have here 2 times 75 over 8 x squared, okay, which is 150 over 8 x squared. And I have to simplify that down a little bit more. Now I would also get an x squared term when I multiplied the x with the negative 5 over 2x, okay, because that x times x, that would give me an x squared as well. So we're going to end up with negative 5 over 2 x squared. And from here we can put this together, and that's going to give us our x squared term overall. Okay, so I'm just going to put it in my calculator. Sorry, I'm not using the one on the screen today, I'm just being a bit lazy. So 2 times 75 over 8 minus 5 over 2. Right, that gives me a simplified fraction, 65 over 4 x squared, and that's my x squared term overall. Okay, next part of the question says to state the range of values of x for which the expression is valid. So again, for this one, remembering that we're looking at any coefficients in front of the x term, so the expression is the expansion is valid if we take the modulus of 5x and that is less than 1, and therefore the modulus of x has to be less than 1/5 if we then go through and divide by that 5. Okay, so there we go. Perfect. Lovely. All right, so we're going to move on to the 4.2 now. So everything we've done so far, you'll notice all of our functions have always kind of looked a little bit like this, where we've got 1 plus x to the power of n. But what if that term, that first value, the constant value in our expansion, isn't a 1 at all? What's our method there? Well, we need to make it a 1. Our expansion's only valid if that first value is a 1. So if we take this first one, where we've got root 4 plus x, and we convert that into 4 plus x to the power of a half. Now we need to make this 4 a 1, and we can only do that by dividing through and taking out a factor of 4. Now you notice there's not a factor of 4 on the x, so we're going to divide that by 4 there. So when we take out that 4, we're going to end up with 4. Now that 4 is to the power of a half because we're not taking it out from the power, or actually I might do this in 2 steps. Sorry, just so you can see that a bit better. Okay, so if we go back, so if I have, so I'm going to take out the 4 as a factor, and then I'm going to be left with 1 plus x on 4, okay, because I've divided that through by 4, all to the power of a half. Okay, now I can see there that I haven't taken that 4 out from the root, so that's still the power of half. So now when I go through again, 4 to the power of a half, well, that's square root of 4, which is 2, so we end up with 2, 1 plus x on 4 to the power of a half. There we go. Okay, so from here we can now do the expansion of this term in the bracket, and we're just going to keep this as a 2, multiplying all of our terms. Okay, so if we now look at the expansion, so we've got 2, 1 plus x on 4 to the power of a half. Well, that's going to be equal to 2, 1 plus a half, half x on 4, okay, plus, I'm just going to quickly pause it, I don't want a video to go for too long, so I'm just going to pause this and finish off the expansion and I'll talk you through it. The expansion follows a normal pattern, just remembering that you've got to keep that as x on 4, because that's your term there. So we end up with 1 plus a half times x on 4, plus a half times negative a half times x on 4 all squared on 2, plus a half times negative a half times negative 3 on 2 times x on 4 to the power of 3 over 6. Okay, then the next thing we can do is go through and simplify those fractions. Again, just do it on your calculator. So you end up with 1 plus x on 8 plus x, this would be minus negative x squared on 128, and then plus x cubed on 1024. Okay, and then we can just go through and we can multiply all of these by 2. and that gives us our full expansion. So that's going to be 2 plus x on 4 minus x squared on 64 plus x cubed on 512 continuously. Okay, there we go. So that's our expansion. Now if we want to state the range of values for which this expansion is valid. So for this part, the range of values so it's the modulus of x on 4 is less than 1. Okay, and therefore x has to be less than, the modulus of x has to be less than 4. Perfect. All right. If you guys want, have a go at that second one yourself and then just pause it and look at the answer. But otherwise, I will go through it. Okay, so I'll just use a different color pen for the second one. So our second example is we're looking at 1 over 2x, 2 plus 3x squared. And again, remember, make sure you always write this as an index power. So we've got that as 2 plus 3x to the power of negative 2. Okay, so now we want to take out our factor, okay, because we want that to be a 1. So we're going to take out a factor of 2. Again, I'm just going to keep that in brackets. So we're going to be left with 1 plus 3 on 2 x all to the power of negative 2. Okay, now 2 to the power of negative 2, you can just put it in your calculator if you like, or you should know that that's going to be a quarter because the negative makes it a fraction, so we end up with a quarter, 1 plus 3 on 2 x to the power of negative 2. Okay, so from here, again, now we can do the expansion. So we've got a quarter, 1 plus 3 on 2x to the power of negative 2. All right, I'm just going to, again, oh, I don't need so many brackets in there. Sorry about that, guys. Okay, so again, if you want to go through and do this, just pause it, then check your answer at the end. Much better than listening to me. But otherwise, again, we keep that quarter out the front. Okay. Then we're going to end up with 1 plus negative 2 times 3 on 2x. Okay, plus negative 2 times negative 3 on 2x. Gosh, I'm not doing well with my brackets today. 3 on 2x all squared on 2 plus negative 2 times negative 3 times negative 4, 3 on 2x cubed all over 6. All right. There we go. All right. Now to simplify this, we're going to end up with 1 quarter. 1 minus 3x plus 27x squared on 4 minus 27x cubed on 2 plus etc. Okay, and again, that's just a simplification from all of that. Okay, and just chuck that straight in your calculator. All right, then we're going to go through, we're going to multiply each term by a quarter, so we end up with 1 quarter minus 3 quarters x, okay, plus 27x squared on 16 minus 27x cubed on 8 plus to infinity. All right, there we go. Now, lastly, our expansion is valid if the modulus of 3x on 2 is less than 1, okay, which is then the modulus of 3x is less than 2, which is the modulus of x is less than 2/3. There we go, and that's our expansion. Sorry, not expression. There we go. All right, all done. I'll talk to you guys on Wednesday. Bye.